Okay, so we left off, we were doing some arithmetic with polynomials, right? That's where we left off last time. So we were adding and subtracting, very simple stuff, very simple. All you're doing when you're adding polynomials, you're just combining like terms. What's that? Oh, whoops, thank you. This thing is kind of a pain. So when we're adding or subtracting polynomials, if we're adding polynomials, we're just adding like terms. It's easier if you just have two polynomials, you don't have to line them up vertically. You really don't. You can just cross them off as you go and just combine like terms. If you have really big polynomials or you're adding up multiple polynomials, that's when it's easier, it really makes sense to line them up vertically and add them vertically. Remember, when you're doing that, kind of the rule is you have to preserve a column for every power of the variable so you can get like terms lining up. So for example, like if I were missing a term in this first polynomial, when I'm writing it down, I'd still want to leave a space there for the n squared terms because there might be n squared terms in the others, right? Does that make sense? Okay, so if you're subtracting, it's really the same thing. Books will show this a number of ways. You could just write the first polynomial down as the first row and then subtract everything in parentheses. And that's okay to do. You have to always remember that you're subtracting vertically when you do that. But I think it can get a little bit confusing if you do it that way, if you have multiple polynomials, more than two, like three or more. I think what's always better to do here, in my opinion, when you're subtracting a polynomial from another one, is just distribute the minus sign and then add. And that way you'd never make mistakes. If you always just distribute any coefficient that's out in front, you can then add them vertically just the way we talked about here. Okay, let's look at one quick example. And I don't want to spend too much time on this because this really isn't a very big deal. So we've got this first guy. I'd want to write this in standard form, right? So I'd have the y squared term first. Okay, and then we're going to distribute the minus sign here. And let's do that. Make that red. So if I distribute the minus sign, and then we want to add these things in order, right? We want to put this into standard form. So minus a negative y cubed is going to give me a plus y cubed, and I'll put that in the y cubed column. I would get a minus 2y squared, so that goes in the y squared column. I would get a plus 5y, goes in the y column, and then a minus 1 in the constant column. And then all I got to do is just add vertically, right, and we're done. So I just get y cubed plus 2y squared plus 6y minus 4, and I'd be done. Okay, no big deal. All right, last issue for this section is when we're multiplying polynomials, what do you do? Okay, we multiply polynomial, like let's just take an example. Let's take number 6, for example. If I've got something like that. Okay, you guys are used to just things like for example, if I were multiplying those out, you would have said FOIL in Algebra 1, correct? And FOIL, there's a pattern for that. First, outer, inner, last, right? Abandon that. That's extraneous. We don't need that pattern anymore. Because when we multiply polynomials, we're always just going to distribute one polynomial over the other one. For binomials or bigger polynomials, it's always the same thing, okay? So for example, with this guy, I've got two choices here. I could either distribute the two terms from this first one over the second one, right? Distribute the w and distribute the minus 7. Or I could distribute all three of these terms over this polynomial. It's the exact same number of steps, but it's just conceptually a little bit simpler to distribute fewer times. And so I would always say it's just a tiny bit easier, in my opinion, to whichever polynomial has the fewer terms, distribute the one with the fewer terms over the one with the larger number of terms. You get fewer rows to add up when you add them vertically that way. And I think there's less of a chance of making a mistake. Okay. So what about this one then? If we distribute the W, we'll just look at this once using our vertical method of tabulating adding up the like terms. So if I distribute the W's, everybody agree I'm just going to get W squared or W cubed plus 2W squared plus W. If I distribute the minus 7, I'm going to get a minus 7W squared, so I'm going to line that up with the W squared column. I'm going to get a minus 14W. So that lines up in the W column, and then I get a minus 7. And then all I've got to do is just add those vertically, and I'm done. Okay, make sense? No biggie. Okay, what about something like, what if we've got something like this? What if I'm multiplying more than 2 polynomials? How would I go about doing that one? What do you think the strategy is? Go ahead, Edley. Okay, good question. Good. So let's discuss that. So the question is, do I multiply the negative 3 by all 3 of those, or do I just multiply it by one of them? You can answer your own question. I'm going to ask you a different question, and we'll come back to this, and you'll answer your own question here. How do you multiply 2 times 3 times 4 times 5? Straight across. Okay. Do I multiply the 2 times the 3 and the 2 times the 4 and the 2 times? I don't, do I? I always multiply in pairs, right? So I would multiply, for example, 2 times 3 gives me 6 times 4 times 5. Now, I could multiply the 4 times the 5 separately and get a 20 if I wanted to, right? Or I could just continue to multiply to the right. 6 times 4 is 24 times 5, and then finally, I get 120. So Adelaide, you answer your own question. Do I distribute that negative 3 to all 3 of those? No, I would just do to one of them, wouldn't I? Right. You could. So you're saying you could multiply those 2 together and those 2 together and then multiply those? Yeah, you could. That's fine. We could do that. I've got a recommendation for you. And that works fine. It's minor issue. My recommendation would be when you're doing stuff like this, I would refrain from distributing until the end. Now, let's just look at this example. So if I took these 2, for example, and I distributed and multiplied those out, we could probably do this in our head. If I distribute the A, I'm going to get A squared. I'm going to get a minus 2A plus a 5A. That adds to positive 3A, doesn't it? Okay. And then finally, I get a minus 10. So all that stuff comes from the green product. So now what? Now I would probably distribute the A to all of these things. I would distribute the 8 to all of these things. And then I'm just going to get another big polynomial, right? When I add all those, when I add those things up vertically. Why would I not distribute the negative 3 until the end? Any suggestions why that might make things just a little bit easier? Yes, think about that for a second. Well, I'm just going to do this math here real quick. If I were to multiply those guys out, what would I get? Whoops, hang on. I got my negative 3 out front. If I were to multiply all these things out, I'd get A cubed plus 3A squared. I'm going to get 24A Okay, if I went through all the work of distributing the A and distributing the 8, that's what I think I should get. I just did it real fast. You could do that easily. It's no big deal. Okay, now I distribute my -3, and look what happens. If I distribute my -3, I just get -3a cubed minus 33a squared minus 42a plus 240. Why did I wait till the last step to distribute the -3? Say it again. Yeah. There you go. There you go, right? It's easier for me to multiply these polynomials out if I have smaller coefficients. Is it a huge deal? No, not at all. It'll work either way. But just in general, if you've got a constant out front, or even a monomial out front, like what if that were a -10a squared or something? You're better off multiplying all of these out with small coefficients and then distributing through with that other monomial or that constant. Does that make sense? Not a big deal, just kind of how, sometimes I just like to talk about little tiny shortcuts, just kind of how does a mathematician think about this stuff? You know, it's just making things as easy as possible is all. Okay? What else? How would I deal with something like this guy, number 9? How could I deal with number 9? Say, good, there you go. Okay, so I could write this as a product of the factor 2c plus 5d times itself is one way I could do that, and it would work. Does that make sense? Okay, I could just expand, and then it becomes a problem very much like number 8. Okay? Okay, good. Question so far? You can't. Okay, that's another good question. So here's the question. I'm really glad you asked that. This is not equal to 2c cubed plus 5d cubed. It's much more complicated. Is that what you were asking? Yeah, it's not that. What this is equal to is 2c plus 5d times 2c plus 5d. Well, you ran out of space, but you get the idea. It's going to be really complicated, isn't it? I'm going to get lots of complicated terms. When I distribute here, I'm going to get c squareds. I'm going to get some c times d terms. It's going to be complicated, right? So you can't just distribute in this case. And this comes back to one of those properties of exponents. This is true, right? We know that a times b to the m is equal to a to the m times b to the m. If I have a product to a power, then I can distribute the exponent to both parts if these are being multiplied only. How come? Here's an example. Like if I did something like ab squared, well, what is that? That's the same as ab times ab, which is the same as a times b times b, which is the same as a squared times b squared, right? Because when I'm multiplying, I can apply the associative and commutative properties and reorganize all those things. But I can't do that. This is not true. A plus b to the m is not equal to a to the m plus b to the m. If I'm adding or subtracting, that does not, I can't apply the same thinking. Okay, good question. Any other questions? That was a really good question. Okay. Okay, so we did that guy. There's really, I'm not even going to go through one of these. There's not even a point. It just would be kind of a waste of your time. If I were going to do like number 10, for example, I would they both have 3 terms, so it doesn't matter which one I distribute over the other one. But I'm going to have to do, like if I distribute from the first polynomial over the second one, I would just have to distribute 3 times, and I would have 3 rows that I'm adding up vertically then to get my simplified polynomial. but it just takes a lot of time. There's really no other benefit to it, okay? All right, so I'm gonna stop recording for a second. So this is the video that'll go with 5.2 practice 1, right? I think that's right, okay, on polynomial arithmetic.